Hello, and welcome back to the Math 0362 final review. This is part 3, and we left off on number 21. So they'd like us to simplify the radical expression. Let's start with the numbers, 250. Alright, there's a problem. 250 is not a perfect cube, but two numbers that make 250 are 125 and 2. I like 125 because 125 is a perfect cube. It's 5. But 2 is not a perfect cube. 2 has to stay in the house. Like so. Okay, we're done with the numbers. Let's deal with the letters, like the letter X. For letters, the trick is long division. So for X16, what I like to do is 16 divide 3. 3 goes into 16 5 times. 5 times 3 is 15, with one remainder. What this means is x5 will go on the outside, and x1 or x will remain inside. Very good. Let's do the same thing with y. So 3 goes into 7 2 times. 2 times 3 is 6, which means one remainder. So what this means is y2 will go outside and y1 will remain inside. So y2 outside, y1 inside. And that is the answer. 22. They'd like us to perform the operation. But before we can do that, we gotta rewrite it where the radicals are the same. Alright, square root of 6. You don't see anything in front of it, so it's really 1 square root of 6. We'll come back to that later. 6 square root 150. 150 is not a perfect square, but two numbers that multiply to 150 are 25 times 6. I like 25 because 25 is perfect. It's 5. 6 is not perfect. 6 stays in the house. But wait, notice there's a negative 6 waiting outside. The 5 on the outside multiplies negative 6 on the outside, so you end up getting negative 30 square root of 6. Alright, we'll come back to that. Next, 3 square root 294. 294 is not perfect, but two numbers that make 294 that you may or may not know is 49 times 6. I like 49 because 49 is perfect. It becomes 7. But 6 is not perfect. It stays in the house. Now notice there was a 3 outside. That 3 is waiting to multiply to 7. So you get positive 21 square root 6. Notice that every single answer that we got has square root 6 in it. So that means we're permitted to add and subtract the numbers in front. So we have to do 1 minus 30 plus 21. And if you put that in the calculator or work it out by hand, you get negative 8 square root of 6. 23 would like us to rationalize the denominator. First, let's take the square root where it's possible. Up top, you see 81. I love 81 because 81 is perfect. It's 9. As for x5, if you do 2 into 5, 5 divide 2. 2 goes into 5 2 times. 2 times is 4, with one remainder. This means x2 on the outside and x on the inside. So I got x2 square root x. 5y is not perfect, so it just stays 5y. Alright, we're almost done. What rationalize means is no square roots on the bottom. And the easiest way to take care of this is multiply top and bottom by whatever's in the bottom. Square root 5y. What happens is on the bottom, whenever you multiply two square roots that are the same, the answer stays the same, but you don't have the radical anymore. Specifically, what I mean is it's just 5y. Then 9x on top, 9x2 is 9x2, and 5y goes inside with the x. So it becomes 5xy. And all of that is the answer. 24. Solve the radical equation. If you ever want to get rid of a radical, the trick is to raise to a power of 2. It's okay as long as you do it to both sides. I like this because raising power 2 just means the square root disappears. So you get 2x minus 5. However, on the x minus 4 squared, that means write the problem twice. And I do that so I can FOIL with itself. So xx is x2, x negative 4 is negative 4x, negative 4x is negative 4x, negative negative becomes positive 16. The negative 4x and the negative 4x combines to become x squared minus 8x plus 16, and it's still equal to 2x minus 5. Okay, because this is a power 2 problem, in order to solve, everybody has to be on the same side. So, let's take a look. What I'm going to do is I'm going to subtract 2x and add 5. So you're left with x2 minus 10x plus 21. The good news is that this will factor. X squared is x and x. And two numbers that make 21 that I like are 3 and 7. Because I can make that 10 if you do negative 3 and negative 7. And then the final step is to write the opposite. So the opposite of negative 3 is positive 3. And the opposite of negative 7 is positive 7. Okay. Technically, you have to check this. So, if you start with 3, you get 3 minus 4, which is negative 1. And then 2 times 3 minus 5. 2 times 3 is 6. 6 minus 5 is 1. They're different. So that means 3 is a bad answer. Let's try 7. Maybe we'll have better luck. 7 minus 4 is 3. Whoops. 2 times 7 is 14. 14 minus 5 is 9. And, wow, square root 9 is 3. They are the same, so that means 7 is good. The answer is 7. 25, simplify. Let's start with the 40. We'll deal with the negative in a minute. It's not perfect, but two numbers that make 40 are 4 times 10. I like 4, and I like it because 4 is perfect. It's 2. 10 is not perfect. So 10 stays in the house. What a negative means, negative on the inside means I. So after you're done, squeeze an I right next to 2. That is it, 2i10. 26, perform the indicated operation. This is actually a FOIL question. So, negative 9 times negative 10 is positive 90. Negative 9 times negative 3i is positive 27i. 5i times negative 10 is negative 50i. And finally, 5i times negative 3i is negative 15i squared. A couple of things are going to happen here. First, the middle. 27 minus 50, that's negative 23i. And then at the end, the I squared means negative 1. But if you didn't know that, you don't have to. What you do have to know is I squared, its role is to change signs. it changes negative 15 into positive 15. As for 90, well, 90 is 90. And what can happen is the 90 and the 15 can add. So you get 105 minus 23i. And that's it. And that concludes part 3 of our exam. So, go back to our website and we will do part 4. Part 4 is only 4 questions, but they involve quadratic formula and graphing parabolas, which not terribly difficult, but it is time consuming. So, tune in a few minutes. Thank you.